the difference with those and annuities do is the time when you make the payments, the regular payments. So for the ones that we've been doing, we've been using this formula. Well, that will be the breakdown of the formula, that is in reality this formula. So with that, since we're making the payments at the end of each period, you could see here how at the end of the first year you have 100, and then you don't start accumulating until the end of the second year. You make your second payment, so then you start making more money. That's when you make your two payments added, and then the interest is compounded. So at the end of the third year, you have this much. At the end of the fourth year, you have that much. So if you add all those quantities, you will get your future value. Now, with an annuity due, the payments are made at the beginning of each period. And because of that, you could make the same amount of money as what we have it shown here. If you have an annuity due for 3 years, or if you have an ordinary annuity for 4 years. So to make the same amount of money, you will have to have an extra year in the ordinary annuity. So if we go from the previous formula to the new formula that we will be using, we're going to say that it has already been shown that you end up with an extra payment if you make your payments at the beginning. So for the annuity due, we're going to use the same formula that we use for ordinary, but then we will be subtracting that extra payment. So let's go ahead and get to our first example. Now we not only subtract the one payment, but we also have to change our n plus 1, our exponent to n plus 1. Because remember, if the time period, let's say, is 4 years, because you're making your payments at the beginning, so then at the end of the 4th year, it will be like the beginning of the 5th year. And so that's why you have to use an exponent of n plus 1. But still, we need to be careful and subtract that payment. So same variables apply here. PMT is for payment. I is R over M, rate, divided by the number of compounding periods. And N is the total number of periods, or also known as M times T. So for the first problem here, we have Jillian will make payments of $500. So this is PMT at the beginning of each quarter for 7 years. So here we get several things. The fact that it says at the beginning, it tells us right away that this is an annuity due, because the payments are made at the beginning. So the time will be 7, and then M will be at 4 because it's quarterly. And the interest rate will be 0.0108. Here it also says compounded quarterly, so that's another reason why M is equal to 4. And so we're going to use the formula that is given to us here. So I'm going to copy that. So the future value will equal to the payment, bracket, parentheses 1 plus I to the power n plus 1, and then minus 1, bracket here, and then divided by I, and then we also need to subtract the payment. So we're going to substitute whatever we can. For n, remember that is m times t, so n will be equal to 4 times 7 for 7 years, so n is equal to 28. For our formula, however, we need n plus 1, so what we're going to be entering there for n plus 1 is going to be 29. Also, another formula that we have to consider is, or variable, is I, which is r divided by m, and that will be equal to the rate 0.0108 divided by 4 because it is quarterly. And we're going to try to keep that in parentheses. And of course, the payment will be in there twice, once there and once here. So we're going to substitute now. So future value will equal to 500, bracket, parentheses 1 plus, parentheses again, 0.0108, divided by 4. We close that parentheses. We close it again because inside the exponent, we want to have that, the whole thing, the 1 plus. And so in the exponent, we will have 29 because it is n plus 1. And then we will have minus 1 here. When you enter this on your calculator, you need parentheses around there. And then we're going to divide, and then here we're going to enter in parentheses 0.0108 divided by 4, close it, and then we will have to close the bracket as well. After that, after you close your bracket, you will need minus and then 500 again. So for that, the future value should be equal to 14,561 with 66 cents. And the way that you will enter this on your calculator will be as follows: 500, triple parentheses, and then 1 plus parentheses 0.0108 divided by 4, close parentheses twice, exponent 29. Then you move to the right side, minus 1, you close your parentheses for the numerator, then divided by, open parentheses again, 0.0108 divided by 4, close it, and then you will close it again. And then after that, it will be minus 500. And so, if you enter that correctly, you should get that as your answer. Now, for our last problem of the section, we have here Shen Wang plans to have a fixed amount from his paycheck directly deposited into an account that pays 5.5% interest, compounded monthly. And let's keep in mind this is a monthly paycheck as well. If he gets paid on the first day of the month, so that's our clue that we will using the annuity due, the one where we use the exponent of n minus 1, and we also subtract a payment at the end. That is the formula for annuity due. And for this one, he wants to accumulate this much. That will be the future value in the next 3.5 years. So that will give us the time. So let's analyze our quantities here. The time is 3.5, so 3.5. M is equal to 12. And from here we could say that N will be M times T. So that will equal to 12 times 3.5. Also, we have that the future value is supposed to be 13,000. And the question here is the payment. What should the payment equal to? So we're going to use the formula, but I'm going to switch the left and right sides. So this will be 1 plus I to the power n plus 1, because it's the annuity due, minus 1, bracket, everything divided by I. So, and then of course minus payment. And that will be our future value. Now, since we are trying to solve for the payment, and you see we have payment here and also here. So we could say that both terms, and I say both terms because this one thing is one term, this is another term. Both terms contain payment. So I can factor payment out of there. And if I do that, if I factor payment out of this quantity, I will still get what's inside the parentheses. And so that would be 1 plus I to the power n plus 1 minus 1, close the bracket, divided by I. And if we factor payment out of negative payment, we will just get minus 1. And so that will give us the future value. However, that's not what we're looking for. And what we are looking for is for the payment. So to solve for payment, we can consider that everything that is here is multiplying to the payment. So we can move it across and divide it, or even easier, we could just calculate what's inside this parentheses here. So that's what we're going to do. So still we're looking for payment. So I'm going to substitute everything here inside my big parentheses and bracket. So this is going to be 1 plus I is equal to 0.055 divided by 12. That's R over M. We close the parentheses once again, and then we will have to use the exponent. And in this case, we didn't calculate that, but n is equal to m times t. Oh, we had it here, but we just didn't finish it. So that was 12 times 3.5 is 42. However, we need for the formula, we need n plus 1. And so that will be 43, because 42 plus 1 is 43. So that is the exponent that we need here. And then we also need a minus 1, a bracket. And of course, when you enter this on the calculator, you need another set of parentheses to enclose your numerator. All of that divided by I, and I is 0.055 divided by 12. And so that is the bracket, and then we still need that minus 1 right here. The future value, actually, that one, we're also going to replace it. And that future value is going to be replaced with the $13,000 that was mentioned from the beginning of the problem. Now, if we calculate all of this in the calculator, we still don't know what the payment is. But we know that from that calculation, we're going to get 46.4103. And here we have 13,000. So that number in parentheses is obviously multiplying to the payment. So if I want to solve for payment, I will have to take that quantity across. And instead of multiplying now, it will be dividing. So 46.4103. And so that will give me a payment of approximately $280 with 11 cents. And so that will be the answer for our last problem.